downtown and I'm pulling up, ready for anything, anyone. Know that I get it done. In the bands, I be pulling up. Tell your friends, cause I'm pulling up.
Okay. Oh, I got it. I think take that. God, that took forever to get that box out of my driveway. Okay, let's go.
All right, fine.
Let's go to my car. God, that box was annoying.
I know, man.
What is it with boxes nowadays?
Yeah, it happens all the time.
God. Wait, what the? What is that?
Oh my God!
Bro, that's impossible, right? Like, you saw me throw that box away, right?
Yeah, it was just over there. Are you kidding me?
What? This just might be a different box. I mean,
Maybe.
This is probably just a.
Boxes are boxes.
I mean, you know, this might just be my family trying to mess with me. I'll push this one. Like, oh my God. Whoa. Oh my God. This was a lot easier to move on tar than on concrete. Dude, this is a lot easier to push once I got it rolling. Oh my God.
What are you doing?
Oh, I'm pushing this box. Wait, move. But, this.
Well, you have fun with that box, bud.
Dude, is it just me, or did that box move by itself?
No, man, you're just crazy. There's no way. That's impossible.
Alright, you can stop. Man, it's cold outside. Okay, man, I'm gonna get rid of this box once and for all. Are you ready? Oh my God, this is actually a lot easier to move in here than on the tar.
Really?
Dude, what's going on here, man?
I don't know. You tell me.
You know what? I think I can tell you. Alright, let's learn physics.
Okay.
So, to show you that my stuff is authentic, look at all these calculations I made.
Wow.
So many.
That is so cool.
Okay, so to understand friction, there are two parts to it. One is static friction, other one is kinetic friction. All right, this might get confusing, so bear with me for a second.
Okay.
They both have the same formula, but this little thing called mu, that is called the coefficient of friction.
No.
It is different for the two types of friction on every single object, on every single surface. So the three surfaces that we face as a challenge today was wood, tar, and concrete. For static friction, wood was 0.25, tar was 0.5, concrete was 0.75. I did some nice calculations on the internet to find these. For kinetic friction, wood is 0.17, tar is 0.30, and concrete is 0.5. So the difference between kinetic and static friction is that static friction is a friction that you need to initially overcome before you actually start moving. This is why I had such hard trouble before I started moving the box. Kinetic friction is a friction that happens once there's velocity involved. So as you're pushing the box, there is friction going against it, but is not as much as static. So, to show you some calculations, I first had it in the equation, it says mu times Fn. Mu is, of course, coefficient of friction. Fn is the normal force, which is technically the amount of force that the ground earth is pushing up on the box. But since the box is not moving up or down in any way, we can say that Fn is equal to the weight of the box. Now, to find the weight of the box, this is a bit tricky. I weighed the box in pounds, then I converted it to kilograms, then I converted that to newtons. So the box turned out to be about 2 pounds. And I multiplied that by 0.4535592 kilograms, because that is how many kilograms is in 1 pound. Now when I have the kilograms, all I had to do is multiply that by 9.8 meters per second squared, which is newtons, and that gave me the mass of the box, which is 8.89 newtons. Right. So I calculated that wood needed about 2.2 newtons for me to initially start moving the box to get over static friction. Then in kinetic friction, once I start moving it, I needed only about 1.51 newtons to keep pushing it. For tar, I needed about 4.45 newtons to overcome the static friction. Then for kinetic friction, I needed only about 2.67 newtons. For static friction of the concrete, I needed about 6.22 newtons to overcome static friction. Then it was pretty easy from there, only needing 4.45 newtons to keep pushing the box.
Thank you for teaching me so much physics, man. You should really get a good grade in any physics class you're ever in, man.
I know, man. I know. See you, man.
Yeah, see you later.